My name is Jeff Forrest. I am the IT director at a church in Colorado Springs called New Life Church. If you're ever in the area, please stop by, visit. I would be happy to host you. And I'm just super honored that you guys would come and hear me talk. I'm also honored just to be able to be here and to help lead at some level with this conference that has given so much to me. Everybody's so supportive, and so I'm just really glad to be here. So today we're going to talk about Wi-Fi troubleshooting for your Mac, and it's kind of a limited. I want to kind of keep the scope, but also limited to what you can do with your Mac. And then I'll share part of my story and just how the approach that I take. And obviously there's so many approaches. I was talking to folks, and a lot of y'all are nonprofits. A lot of you are schools, universities. You've got governments. You've got big budgets. You've got small budgets, no budget, right? So we're going to try and meet everybody where they are as far as that goes, and just give you some tools. All right. So some of the goals for today, right, is just to understand some of the basics. As a IT director, my hands are in everybody's things, right? So, but I have to communicate that to non-technical people too. So I want to make sure I'm not talking down to anybody, but also still giving you a lot of the information. So we're gonna talk about the basics of Wi-Fi. Maybe you've never understood this, right? Because it's invisible, right? You can't really see it. So I want to make it visible for you, right? So we're going to get those tools. We're going to use the built-in tools that Apple's given us, as well as some inexpensive tools. And for me, if it's less than $1,000 or closer to that, couple hundred, that fits my budget for being at a church, right? All right, and then hopefully we'll find some solutions, or just suggest some solutions. I was talking to some folks that are in education, right? You're maybe not the network guy. That's not a hat that you're wearing, but you need to troubleshoot that, right? The network, everybody rides on the network. It's a commodity that all of us need, and we all want it to be great. So maybe you can just collect information and pass that on to your network guys, right? So let me just share a little bit of like my history, and again, this will just show you kind of my thinking and when I fell in love with Macs, right? So out of high school, I joined the Army. I was a medic. I thought I wanted to be a doctor, right? But then I learned that nobody does anything that you tell them to do to take care of themselves. So we'd always have people falling out from dehydration. They're always eating poorly, smoking, and then hoping that they'll be able to run 2 miles without passing out or whatever, right? And that was really frustrating to me. Exciting, but frustrating. So I thought, hey, I'll get into computers out of the Army, and I'll go to a different boot camp, right? I'll go to a A+ boot camp and learn all about Windows, because computers do everything that you tell them to do, right? Yeah. So man, I was really blessed. Straight out of this boot camp, I was able to work for a Fortune 500. This was during all the kind of the .com boom, and right, there was a pets.com, socks.com, who knows, everything.com, right? So I worked for this company, York International, that was headquartered here or in Pennsylvania, and that was great because I got exposed to so many things. And one of the things was marketing guys, and they were, publishing and creating brochures and videos and all that types of things on their Macs. Well, I was always just making fun of them, right? Because I was a Windows guy, but they needed our help, right? So, hey, I'll help you. But they were great. They kind of showed me things. They were like, hey, actually, this is all built on Unix and things like that. And we had these mainframe AS400s that I learned all about while I was there. And so they were like, yeah, you can edit video and administer the AS400 on this same machine. And I was, when they got an upgrade, I was like, hey, crusty marketing guy, can I get this old G4? So I had that hooked up on my little KVM under my desk. But for me, that was like this legacy, this foundation of stability, as well as creativity. I really liked, and that gave me this intro to video editing. And I ended up I wanted to get more into that, so I found this great journalism class at our community college, and in that class I learned everything about shooting, recording video, audio, and editing all of it. Great class, one class, and ended up getting a job editing videos for our church, and that kind of pushed me kind of down that nonprofit path. But the power and the flexibility of having a 12-inch PowerBook on my lap, capturing from a DV camera. Some of y'all are crusty like me, right? And you remember some of this old style, but this was like revolutionary. And so that revolutionary part and creativity part of Max has always been amazing to me. And then as I started working with nonprofits, children's hospitals, churches, I started just realizing how long, I still have that 12-inch PowerBook. It still works. I obviously don't do it for a whole lot, use it for anything really, but it's just nostalgia. But the quality of Apple products is amazing to me. And just being able to, when I first started at this church, we were shifting everybody over to Macs, and they were like, why are we buying Macs? In our world, our accounting team says we're spending people's worship. Right, so every time you're spending something attending this conference, we're like, man, this was an important dollar to them. So for us, we want to be good stewards of all that money. So we just, the Mac, initially there was a lot of resistance, but now that we have these Macs that have lasted a long time, they're still usable. We can donate them and they're still usable. It's really nice. So all that to say, I love the Mac, and I just want to let's talk through just the power that they give you, the flexibility, the creativity. All of that is amazing, and so the approach is to save money and improve the experience for all your users. So let's go through some Wi-Fi problems. Has anybody had any issues with Wi-Fi this week at all? Right? What's that? Yeah, not yet. And if we do, I'll be amazed with myself. But welcome to conference Wi-Fi, right? It's always this way because there's a lot of density, and in a conference like this, right, it's going to be different than another conference where not everybody has 3 and 4 devices that are all syncing. They're all getting push notifications. They're all, every one of your devices. It's like having another person in the room, right? So conference Wi-Fi is a challenge. In my world, in a church or an event Wi-Fi, it's a lot different, right? Because they're not working necessarily, right? Like some of you in this room are having to work right now, right? So you're uploading larger files, all those types of things while attending the conference, right? So there's a lot of challenges with conference Wi-Fi, right? And it's just notoriously slow, right? So some of the things you'll experience is dropped connections, right? You're doing something, then all of a sudden it drops off, right? So that can be coverage, can be interference, could be too much utilization. You may experience slow speeds, right? That usually is going to be a signal strength or too many clients, too many people, too many devices doing too many things at once, right? And then sometimes you may be connected but not have any internet, right? So that could be a misconfiguration issue, right? So a lot of network guys, it's always DNS, so they're going to blame somebody else, right? So that's fine. If you don't have working DNS or misconfigured, or the gateway, you're not reaching the gateway, so that could be a VLAN issue or something like that. Those are things that if you can just gather that information, you can pass that on to your network guys or make that change yourself, right? So let's talk about some of the basics of Wi-Fi. So Wi-Fi is unique in that it's shared, right? I like to use this walkie-talkie radio thing, and maybe that's the Army guy in me. But we had we had hours of classes of how to communicate across radios, right? Because you have to wait, or otherwise you're stepping on somebody else. They can't transmit. All they can do is receive what you're transmitting, right? There's this, it's a shared medium, so you have to wait. So I like to use that analogy. So right, like if you're on a phone call, right, we can both be talking at the same time, generally, right, and both hear each other, both be talking at the same time. You can, raise your voice to be heard more, right? I'm trying to use these analogies that are like, okay, like so you're raising your voice is more analogous to having a stronger signal, right? And it's really amazingly fast. If you get into this and you start capturing packets, you see how much is happening at a millisecond level. If you make a big screen or capture of packets, you'll have a time stamp for each one of those packets, and it's amazing how much is happening in the background. Again, it's invisible, right? But you cannot transmit and receive essentially at the same time, except for, there are exceptions to that with MIMO and some of these other things that we'll talk about. But in general, it's a lot like your classroom, right? So if any of you had a question right now, what would you do? Yeah, you would raise your hand, right? So this RTS, CTS, the RTS is request to send, right? Teacher, I don't understand this, right? The clear to send is the teacher acknowledging, right? Go ahead, let's hear what you got to say, right? What's your question, right? There's the teacher acknowledging that. And then also in Wi-Fi, there's this acknowledgement, right? So if you're again, using that classroom analogy, you share with the teacher, and the teacher just looks over your head, and does not connect with you, right? That probably means they didn't hear everything that you said, right? So there's this. I'm just trying to give you some of these analogies, right? Of a teacher, a classroom. The more full the classroom is, and everybody's trying to talk at the same time, right? They can't hear the teacher. There's all these different ways to picture it that we've all experienced, right? So if your teacher's not nodding as you were talking, right, they're not acknowledging. In Wi-Fi, there's kind of the same method of saying, hey, I got your packets, and letting you know, right? In the Wi-Fi world, if all the packets don't make there, if you don't get that acknowledgement, you're eventually going to send it again, right? You're not getting that acknowledgement from the teacher, right? So you're gonna speak up. You're gonna say it again, right? So you got to wait your turn. If there's interference, right? So another thing is different people talk at different speeds, right? I have one of my coworkers here, and she was telling me that she listens to audiobooks. Was it 3x? Or you're looking at an app that does 4x? Okay, that's insane to me, right? But that's amazing, right? Some people have that kind of processing power for audio, right? But maybe you don't, right? So I don't, right? So I'm a 1.2, whatever kind of speaker. But you in a classroom, again, I'm going to use this classroom or walkie-talkie scenario. If you've got a slow talker, they're taking up that bandwidth, all right? And there's only so much bandwidth. And remember, only one person can talk at a time, right? So the slower talker is bringing down your network, okay? And some of that, it can be like no fault of their own. If they're distant or other things are going on, it can cause that slowness, all right? It can also, I want to share like an interesting thing that I learned a while back. There was this airport study, or the study on the Wi-Fi at the Denver airport. And they were trying to figure out how can we improve. Like there was limits, there was nothing new coming out. We've already tapped out, we've already bought the best we can buy. The network connections are the best we can get. What else can we do? And somebody had the idea of this kind of slow talker scenario of let's get people off the network as soon as possible, right? So in an airport world, you're waiting for your flight, but you want to download a movie, right? You want to download some TV shows, something like that, right? That's significant. And back in the day, I think this was 2017. That was a significant amount of data to download, right? So they would have people just sitting there and downloading. And you can imagine it's just a large download. Well, they had a 15 megabit client limit, right? So they had set the speed limit on their people, right? So they had said, man, we're trying to share all this bandwidth, but we don't want someone to just take all of it, right? So we're going to slow everybody down. Everybody's talk at 15 megabits, right? If you're a guest on our network, talk at 15 megabits, right? Well, that turned out that there was this extended amount of time that people were trying to download videos and things like that at 15 megabits, and they're like, well, I got 3 hours. I'm waiting for my plane. I don't care. Turns out, though, that was bringing everybody down. So they said, let's just do a pilot run. All right, we're going to take that limit off and see if the experience for people goes up. And it did dramatically. So people were able to download at gigabit speed, or it was probably 600 or 800 megabits speed, right? But instead of a download taking 3 hours, it would take minutes, right, to download those things, right? So a pinpoint high speed impact on the network, but it wasn't this long, drawn out, nobody is getting done because of this slow talking, all right? So now, excuse me, Denver Airport is just recognized as having great Wi-Fi. So people, they don't mind. So, all right. So let's talk then about and compare frequency bands, right? So for the most part, all of us are going to have right now 2.4 gigahertz and 5 gigahertz Wi-Fi, right? These are the primary bands that we use. It's measured in gigahertz, and we give them channel numbers so we don't have to remember all that stuff, right? So we've assigned certain channels to them. And let's compare, right? So you've got range. You're going to get better range out of 2.4 gigahertz, right? These are much larger waves, right? So if you picture waves in an ocean, they're coming at still very fast, but a slower speed than these 5 gigahertz. So a big wave, right? It takes a while for the energy to dissipate, right? Smaller waves, smaller ripples, right? The 5 gigahertz would be these smaller waves. They're arriving a lot faster, but they're not able to go through walls quite as much, right? So that's where that range, your 2.4 gigahertz is going to give you that range. But because it's slower, it takes a little while longer, so you're not getting as many packets, as much bandwidth inside of that, all right? So we talked about speed, and then congestion. 2.4 gigahertz is slow, or it's much noisier. There's so many things that can interfere with it, and we'll talk about that in just a second. Some of y'all have maybe heard of 6 gigahertz, right? That is coming, like Tarzan to the rescue, swinging in, and it may help us in some of these conference high density worlds, and hopefully it's going to help for a long time, but we'll see, right? So currently, it's, if you have a newer MacBook, you've got, an iPad Pro or newer iPhone, they're going to support that 6 gigahertz when it comes out. But the APs are a lot more expensive. Plus, you've got some infrastructure upgrades that are going to have to happen, right? So a lot of those are going to run on 2.5 gigabits Ethernet or 10 gigabit Ethernet. And then you may need PoE++. You may have more power requirements, more switching requirements, more cable requirements. You have all this kind of back-end stuff that you're probably going to have to upgrade to get that. So, but it's coming. It's coming. And the AP costs will come down as well. But there's just all this extra work. So, but that's our Tarzan to the rescue as far as that goes. So, all right. So we talked about some of the distance. Let's talk about interference. All right. I stole this image from MetaGeek. It's an old image, but it's great and just to fit all of that together. So we talked about co-channel interference, which is if there was only one AP, I think I only see 2 in here, which is fine. What's that? Oh, okay. If there was only one AP in here, right, and that's okay because everybody's working on the same channel, and there's this cooperation, right, that can happen. Co-channel interference is really just congestion for the most part, all right? You're still, there's this polite cooperation, again, this raising of the hands and things like that. Adjacent channel interference is every client is talking, every AP is talking, if they can hear each other, right? So we've got an AP here, there's one kind of in the middle, same range, or same position rather. They can hear each other for sure, unless the power is extremely low, right? If they're on overlapping channels, right? So in the next slide, we're going to talk about non-overlapping channels, but if they're overlapping, there's no coordination, right? So we can hear the folks next door, right? If they were super loud, right? You ever been to a movie theater and you're watching a rom-com with your significant other, and next door is the new Fast and Furious in space 14, right? So, right, and everything's blowing up. Vin Diesel is like, hey, right? And, at the worst moments, right? That's that adjacent channel interference, the noise that's not coordinated. It's not together with and it's just kind of a disharmony, right? And then, especially in the 2.4 gigahertz, you've got sensors for building sensors. You've got microwaves, Bluetooth LE, Zigbee, a lot of different things that are all in that range, that 2.4 gigahertz, that are just this low-level noise, right? Has nothing to do with your data or with internet data, but it still is interfering, right? So again, it's kind of like that. Just if the whole back of the room was just murmuring and there's just this low noise, right? It would be like that, all right? And there's ways to get around that again. Let's talk about that. So let's look at the frequency bands. This top image is the 5 gigahertz band, usable band. We've got frequencies that are measured. So we measure the width of the frequencies in megahertz, right? 20 megahertz, 40 megahertz, 80, 160. Later on, we'll have 320 megahertz, right? But if you look at this, right, they're broken down into how many channels you can get within there, all right? Your Wi-Fi router at home is really only going to live in the green realms there at that 5 gigahertz. And the blue is what we call DFS channels. Those are ones that are shared with radar, weather radar, And you are essentially, if you use those channels, and they're really only available to like managed systems, your enterprise level systems, you're taking that into consideration. You're saying, if I use this and a Doppler radar, an airplane, something like that, like airports, big metro areas with lots of news stations that have their own radar. I'm from Oklahoma, where they're the king of radar, and you really like the National Weather Service is like headquartered there. They train everybody there. You can hardly use DFS in and around Oklahoma City. So those blue channels are available, but you might get kicked off. All right. So let's talk about. So these are all non-overlapping channels, right? So if you have, let's say, classrooms, right? You've got a whole hallway of classrooms. You're probably going to have to use the 40 megahertz for, you want enough bandwidth because it's a classroom. But if you look at it there, you've only got 4 channels in that green, but you've got 12 if you include the DFS, right? So again, some of that is just a gamble of using that, all right? But you want to try to coordinate those frequencies. So this is going to come in, key here in just a little bit, all right, of when we start looking, again, seeing the invisible of what's in the air right now, right? We're surrounded by Wi-Fi, all right? All right, so one key part for the channels, right, is signal strength, right? So we talked about 2.4 gigahertz versus 5 gigahertz. Let's talk about like what else affects signal strength? Well, you do, right? The number of bodies, the humidity and rain can affect it. Walls can affect it. Glass affects it differently than drywall. Bricks, yeah, a lot of people are nodding their heads, right? Folks that are from Europe, right, have these really thick concrete walls, not like our silly drywall that we have here, which is like great, it affects it, but it's not as much, right? And with signal strength, you've got different clients, different devices are putting out their signal at a different rate. Part of that's just because they don't have as much power, right? So your laptop, your iPhone, right? They've got a battery to manage, right? So they're trying to balance performance and power usage, right? So they want to give you all the speed so you love them, but they don't. If your battery is constantly draining, that's another thing, right? Access points, they've got all the power in the world, so really they're just trying for coverage, all right? We're going to look at signal strength. Right? Signal strength is measured in dBm, decibels per milliwatt. So again, that's a measure of power, actual electricity, right? Or output rather. All right, and I'm going to skip the 3 and 10 rule, but essentially you can look at that later. It's logarithmic. So if you're an audio guy, this makes sense, right? I'm not really a math guy, but I can understand 10x or a 10-point improvement in dB is roughly a 10x improvement in signal strength, all right? That one's easy. So we talked about devices, all right? Your iPhone and iPad. This is really key whenever you're looking at your design is what are we using this room for? What are we expecting this room to have in it, right? So if you have classrooms, if they're filled with iPads and things like that are lower power, they're looking to roam whenever the signal gets to this minus 70 dB, all right? And they're only going to roam if they find an access point that's about 8 dB stronger, all right? Your Mac is 75 and 12, right? So If you're on your Mac and your signal strength gets to minus 79, right? You need an AP closer if you want a better signal for it to actually want to roam. That's going to be at minus 67, right? So this is really important as well for your layout. So when we get to these tools and you start seeing the different signals and what levels they're at, you're going to go, man, I'm seeing all of them in this one area, or I'm not seeing enough access points available to me that are powerful enough. Well, now you understand why you're stuck, right? You're stuck on one access point with 130 other people times 3 devices, right? So let's talk about tools. A lot of y'all already know about these built-in tools. The option click on your Wi-Fi icon. So this is just an example from my room. And so let's just kind of go over what we see here, right? So if you hold down the option key and click on your Wi-Fi icon, you're going to see the network name, right? That's an SSID, right? Are you connected to the right network? That's a great place to start, so always double check that. All right, the BSSID just stands for the base station signal ID, right? So that's the access point that you're connected to, or maybe an antenna on that access point, because most of our access points these days, they have multiple antennas, multiple streams, spatial streams. That MIMO comes into play. It's going to show you what channel you're on. So I was on a DFS channel, all right, and we're working fine. I was working fine, but if there was some radar interference, it may switch over, all right. The RSSI, that's your signal strength, right? That's what you're looking for. Remember we talked about, when am I roaming? And that's your signal strength there, measured in this minus 66 dB. All right. Noise is how clean is the frequency. Again, we talked about if everybody's murmuring, there's this noise in the room, we're not going to be able to hear quite as well, right? Again, I'm just trying to simplify some of these things. NCS index is a comparison of what frequencies, what technology it's using, and what compression it's using to give you essentially just a score to let you know. So the higher the better. If you're not 4 or higher, you're probably going to be having some challenges, all right? And then the NSS, that's your spatial streams, all right? So if your MacBook has 2 MIMO antennas, right? It's capable of these 2 streams on the highway. It can have 2 conversations, essentially. That's what you're seeing right there, all right? So let's look at, these are some of the tools that maybe you haven't seen, all right? If you got your Mac in front of you, you did that option click. If you go to wireless diagnostics on that option click, you've got a couple of options. I like these 2, the Windows scan, all right? And that will show you all the available frequencies, all the available access points around you, all right? Show you the channels. Is everybody doing that? Have you tried that? Let me get out here. Oh, you know what? We're kind of running out of time. I'm going to encourage you to do that later, all right? As well as the performance. This is the performance screen. It can essentially just show you what's going on as you're using it, all right? And if you're just trying to improve your own experience, you can follow that and find the nearest access point, a closer access point where you get a stronger quality, stronger signal, lower noise, all right? All right. Here's a couple terminal commands that are helpful. Like we talked about, everything always comes back to DNS. Not always, but with internet, if you don't have working DNS, you can go to terminal, type in dig, google.com, and it will show you, where is Google. It'll give you that whole DNS reference, what was the responding server, all of that. NetTop is really nice too. It'll just show you kind of a network summary of what's going on. All right. But let's talk about some third-party tools. All right. If you've got a Meraki, you've got Aruba, you've got Cisco, this is a Unify screenshot. We use Unify because of cost and everything else, right? It's probably got a vendor dashboard built in, right? And it's going to show you, maybe have an option for you to scan right then. I probably wouldn't do that during a conference unless it has a built-in scanning radio, because you're going to kick everybody off that radio, that access point, all right? But you can do this later, all right? But this is something you probably already have if you have a managed Wi-Fi solution, all right? One of my favorites is Wi-Fi Explorer. I like the Pro version. It is $149. You can buy it from IntuityBits or in the App Store. So you can deploy it through the App Store too if you are so inclined. But it's got this great interface, and I'm hoping to have enough time to just show y'all some of those basics where it will actually give you that visual representation, right? So we talked about overlap. That's where this comes in, right? So you see on that left-hand side, there's a lot of overlap of different access points. This can just give you that quick visual representation. $150 could save you a ton of time, right? Another tool, I hadn't used it for years, but I was like, let me see if they're still kicking, right? Is NetSpot. There's a free level one that kind of gives you essentially the built-in diagnostics. It gives you that scan reference where it shows you all the channels there. But it has the benefit of doing site surveys. So a site survey is you would just walk around with your laptop, right, and you just see what your signal strength is. They have definitely improved it a whole lot, and it's really nice. So I think it goes all the way up to $699, which is their enterprise level, multiple technicians, all this type of stuff. It can let you do some planning for, like if you put in your a map of your facility, you can plan where everything's going to be, all right? So I would definitely look into that as well. Then we can talk about capturing. Remember we talked about capture and how much is actually happening? This is a little more advanced, but AirTool makes it super easy for you to capture. So let's say you're not the network guy, you're not responsible for fixing it, but there's a remote person, an MSP, somebody. This makes it easy. Or maybe you're the MSP and you need people just to, hey, can you just do a capture and send me that file, upload it here? You give them the parameters, and AirTool will do that. And make it easy for your people, all right? And it can automatically export it to Wireshark. It can upload the packets. It can do CloudShark, but I just recently learned CloudShark is super expensive now too, so, but it's really nice. So take that as you will, all right? And then we come to Wireshark. I don't know if we're going to have enough time. I'm going to come back through and just show y'all briefly all these tools, but I put on here, Wireshark is really complicated. You can get certified in it now, and you can do a ton with it. I like to just get a summary. So what I like to do is if you're in Wireshark, you can go to statistics and IO graphs there, and it will show you, so some of these lines here are retries. So you see as the packets go up, this was pretty good, all right? The retries didn't necessarily go up exponentially on this network grab that I did here. If you do statistics on the menu and then go down to endpoints, you can filter or organize by how much data somebody's used. So you can find that guy at the airport that's uploading or downloading downloading a movie, right? They're taking up all the bandwidth, right? So maybe it's a specific client. This is super easy. It's super easy. Wireshark can be super complicated, but this is just ways to make this easy. So if you are interested in that at all, please, get these slides afterwards or take a picture of that. The analyze and expert info is awesome as well. So it will categorize, it'll go through every error, it'll filter that for you, and hopefully I can show you that real quick and just give you, if you have any knowledge of networking, you can go, oh, I see a ton of retransmissions, or it looks like DHCP is not working, right? So you'll start seeing patterns. So I love to use Wireshark just for that. I'm not that great at filtering everything else. And then this export to CSV, it wouldn't be 2025 if I didn't mention you could just also export to CSV, put it in your Gen AI of choice, and say, hey, you're a network consultant, a wireless expert. Look at this capture and tell me what's going on, right? So I'd be lying if I told you I didn't do that. So let's look real quick. Go about 4 minutes. All right, I just want to show. Hopefully y'all can see that okay. So this is Wi-Fi Explorer Pro. Crazy amount here of channels, but let's just focus on the 5 gigahertz because I kind of just ignore 2.4, right? I'd love to just show how you can organize networks by access point in here or by the name, right? Just kind of the default for most Wi-Fi analyzers, all right? But you can add these columns in here for signal to noise ratio. This is going to be more important for you, I think. As well as it'll show you channel utilization. So see how this AP here, you got 74% utilization. If you're on that one, you could be struggling, all right? If you're not super nerdy, you can come in here as well, and you can change the signal strength to percentage. These are just helpful tips. You can kind of filter out. So I usually like to put this, I gotta use my glasses, Lord help me, for about 85 or 80 and filter out, right? And so then I've got a signal strength, which is a little bit easier to understand, right? So that's really nice. If we go into net spot, I don't love this look as well. It's not as helpful for me to not see those channels kind of overlapping, but it kind of gives you the same thing that the scan in Apple does. But if you do let's say you just say after an event, after a conference, you go back in and you say, I'm going to do a survey of where we are right now. You can come in there and you can load that up and you can see kind of what your coverage is. They've got these built-in troubleshooting things, right? So if I select, this is every AP that it sees or saw, right? So hypothetically, if we were on every one of these networks here, we'd be able to see or connect, like green is great, right? Or usually red is great, right? So, but it will show you where you've got overlapping channels or if you're good, right? If you've got questions about signal to noise, you can go in here and compare those as well. So it's a really nice, for a snapshot, it's really nice, all right? And nice. In Wireshark, I just wanted to kind of show you all that these different graphs. Again, it's just really nice to be able to filter through, show, okay, this guy, 10.40, he's, during this 2 minutes is downloading, and that could just be completely innocent. It could be OneDrive, right? Something like that, just syncing in the background. But anyway, I think that's it. Any questions with our 10 seconds that we have remaining? Sorry, I did not expect to be that close on time, but yeah, thanks again, everybody. I appreciate your time.